We're here on review number 2, question 5, and it reads, some values of functions f, g, h, and k are provided in the table below. Find a possible equation for each function. So I've recreated the table here. I just want to state that the exponential formula is f of x equals ab to the x power. And the linear, most of you have heard of before, is f of x, or y, equals mx plus b. So we're going to look at this first one right here, f of x. So we have 80, 40, 20, 10, 5. So each one of these are decreasing, so that means it's going to be dividing. We're dividing by 1/2. You see it goes 80 or times 1/2, or divide by 2. So if it's division or multiplication, it's going to be an exponential. If it's adding or subtracting, it's going to be a linear. So this one is going to be an exponential. So it's going to look similar to f of x equals to 80 is going to be our a, because it's initial, it's equal to 0. So 80 will be our a, and then our b will be the rate of change. So because that is decreasing, we're going to be multiplying by 1/2. So it's not 2. If it went 80 to 160 and so on, that would be a 2, but it's decreasing, so we're going to put it at 1/2 to the x power. And that's your f of x equation. Alright, so now let's look at g of f. It goes 80, 40, 0, -40, and -80. So this looks like it's subtracting 40 at each time. So this means it's going to be a linear equation. So we'll start off with g of x equals to -40x, because we're going down 40 every time, and then, which is different than the exponential equation, this b is going to be our initial value, so it's going to be 80. So this linear equation, it's going to be g of x equals to -40x plus 80. Alright, we'll do the h of x next. So we got 5, 15, 25, 35, 45. So this one, you can obviously tell that you're going up by 10 every single time. So it's going to be 10 of x, or 10x, plus our initial 5, plus 5. Pretty straightforward. So let's do our last one. K of x equals to, so it goes 5, 15, 45, 135, and 405. So our initial is 5, so we're at x equals 0. And in parentheses, you can see 5 times 3 equals 15. 15 times 3 equals 45. That means our rate of change is going to be a multiplication of 3. So know that it's an exponential equation. So that's our answer there. So you have to be careful when you look at the graph to find the initial values. If this line wasn't here and you just started with the 1s, you'd have to find your initial by using the rate of change. So if you just had 40 but realized that this was dividing by 2, you'd have to know to do the opposite and do the 80. So you always start from 0 for your initial value. Same goes for, let's say, h of k. You know that it's the difference of 10 between 15, 25, 35. So for 15, you have to subtract 10 to get your initial 5. Well, I hope this video helps you on exam review number 2, problem number 5.